I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a world where light doesn't just help us see, but actually helps us heal, detect disease early, and even monitor the environment. Welcome to the age of biophotonics, where cutting-edge light-based technologies in biology converge to revolutionize medicine, diagnostics, and sensing. It's not science fiction anymore. It's happening today, and it's transforming the way we understand and interact with life itself. At its core, biophotonics studies how light interacts with biological materials, cells, tissues, and molecules inside living organisms. By using different wavelengths of light, from visible and infrared to ultraviolet, scientists are creating powerful tools that capture images at the molecular level, detect diseases early, and even enable real-time treatment. Traditionally, radiology has relied on X-rays and gamma rays, high-energy light, to see inside the body. But biophotonics flips that script. Instead of damaging radiation, it uses lower-energy light that's gentle on biological tissues while offering super high-resolution views. This means doctors can now see cellular-level changes, like early genetic mutations that may cause cancer, or early signs of neurodegenerative diseases such as multiple sclerosis without invasive procedures. One of the game-changing innovations is the Surface Plasmon Resonance sensor, or SPR. Imagine a gold-coated chip that detects tiny molecular interactions in real time. How does it work? It measures changes in light waves along the metal surface when biomolecules like antibodies or antigens bind, shifting the resonance frequency. During the COVID-19 pandemic, portable SPR devices enabled rapid antibody testing right at the patient's side. This wasn't just a laboratory miracle, it was a revolution in point-of-care diagnostics, allowing doctors to detect not just viruses, but early Alzheimer's disease markers before symptoms even appeared. Alongside SPR, Surface-Enhanced Raman Spectroscopy, or SIRS, amplifies weak molecular signals up to 1,000,000 times. How does it work? It uses nanostructured metal surfaces to boost light interaction with molecules, making their tiny vibrations detectable as unique fingerprints. SIRS can detect pathogens like Salmonella or SARS-CoV-2 in saliva samples with incredible accuracy, all in under 30 minutes. This is the future of diagnostics: fast, accurate, and accessible even in remote or resource-limited settings. But biophotonics doesn't stop at detection. Technologies like Optical Coherence Tomography, or OCT, are changing how surgeries happen. OCT works like ultrasound, but instead of sound waves, it uses light to measure the time delay and intensity of reflected light, creating high-resolution cross-sectional images of tissues. Whether mapping the retina to prevent blindness or guiding surgeons during delicate brain operations, OCT is making interventions safer and more precise. What makes this field even more exciting is its marriage with nanotechnology. Tiny materials like quantum dots, semiconductor particles that glow when hit by light, enable multicolor imaging of cancer cells in living organisms. Graphene-based nanosensors work by converting molecular interactions into electrical signals, giving real-time glucose monitoring. At ETH Zurich, light-guided nanobots use focused lasers to navigate and deliver drugs precisely to brain regions, showing promise in treating Parkinson's disease. On top of all this, wearable biophotonic devices are right around the corner. Picture smart contact lenses, embedded with biosensors. These work by using tiny light sensors that detect biomarker changes in tears, transmitting the data wirelessly for continuous monitoring of glucose or intraocular pressure, providing non-invasive, real-time health insights without a hospital visit. Beyond human health, biophotonics plays a huge role in environmental monitoring. Portable sensors equipped with photonic technologies detect microplastics in water by shining light and measuring the specific way microplastic particles scatter or absorb it, down to parts per million levels. These innovations are supporting global efforts to clean our planet. Of course, like any revolution, challenges remain. High-end equipment can cost hundreds of thousands of dollars, and handling massive data from imaging scans demands powerful AI tools. But innovations in 3D printed microfluidics and advanced algorithms are making these tools more affordable and smarter than ever. Looking ahead, the fusion of AI, nanotechnology, and biophotonics promises not only earlier, more precise diagnostics, but also personalized, on-the-go health monitoring and smarter environmental sensing. Soon, devices like miniaturized OCT systems and handheld spectroscopic analyzers will enable doctors in remote areas to detect diseases instantly and make real-time decisions. As Dr. Li Heng Wang puts it, biophotonics turns light into a healing force. Today, this force is growing stronger than ever. In 2023, the global biophotonics market was valued at $67.81 billion and is projected to expand at a robust CAGR of 10.2% through 2030, fueled by breakthroughs in medical diagnostics, therapeutics, and environmental sensing. At the same time, global biophotonics funding surpassed $8 billion in 2023, accelerating innovation and bringing life-changing technologies closer to everyday use. So the next time you think about light, don't just imagine illumination. Think about saving lives, detecting disease in its earliest stages, and protecting our planet, all powered by the science of biophotonics. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.